At Loam, we want to work with some of the best scientists in the world, and in the soil carbon space, one of the natural choices is the University of Queensland. So Professor Ramdalal has decades of experience in the area of soil science, specialising in soil carbon, and he's recognised internationally and in Australia as an expert in the field. So it's a natural choice for Loam to want to partner with that kind of expertise. Dr. Vijaya Singh has special expertise in the use of riser boxes to understand how plants interact with soil and microbes. And that's why we're really excited about this collaboration.
So when I started this work, we were mainly looking how this fungal inoculant, which is produced by Loam Bio, influences root architecture, which is my specialty, and then how root architecture influences carbon sequestration and drainage.
Soil carbon is important for a number of reasons. For fertility, it's also a building block for aggregates, soil physical properties, so that water or rain gets into the soil easily and is stored there.
Initially, sorry to say, I was a bit skeptic because I thought, no, these little tiny microbes cannot increase that much carbon or cannot make that big difference. But when I did the work at Gatton in the field, we could see that how the fungal inoculant not only increased grain yield, but it increased carbon in the soil.
Researchers at the University of Queensland have inoculated seeds, and then they have either put these seeds in riser boxes in the greenhouse or in field trials. And as those plants have developed, they've unpacked the riser box to see how the roots are growing through the soil. And in this way, they can study how soil aggregation happens and how Loam's fungal isolates are driving different root phenotypes.
So it is very, very interesting to see that directly here. Once the roots are being washed, you can actually look at that effect, and that makes it very interesting for us as well to kind of find the treatment response when that is. But the analysis will tell the difference, but it's always very exciting to see this firsthand when the washing is being done and you're able to see the nodules, and you kind of get very excited saying that, oh, this is the response, this is what you're after.
So as these fungi can grow through the soil, they can cause soil aggregation, which can stabilize carbon and also stabilize nitrogen in the soil. And that was what was really interesting about these studies at the University of Queensland. They saw with soybean in the field an increase in carbon at the same time as an increase in nitrogen. Obviously, what's most exciting about that for farmers is at the same time there was an increase in root mass and grain yield.
For me, I come from Indian background, so I've seen a lot of poverty there, and food, hunger is already there, and we have to build our soil. How this product can improve the soil fertility, build carbon in the soil, improve water storage capacity of the soil, because you can see a lot of places, even in Queensland, you go in central Queensland, water falls and it runs off because there is no infiltration, because we've lost that carbon, the microbial community. And if we can build over time to put carbon back in the soil, that's exciting for me. Like, for me, it makes a big difference if I can be part of that, actually.